Right, the next topic then, or subtopic in the aggression topic, are the neural and hormonal mechanisms that are behind aggression. And this forms part of kind of the next section of the topic, I suppose. So the first part was looking at almost the psychological side of it, or as the spec says, the social psychological approaches. And that includes the social learning theory, de-individuation, and institutional aggression. The next part then focuses more on the biological explanations of aggression. So it's saying why biologically are some people maybe more aggressive than others. So this first lesson is going to look at the neural and hormonal mechanisms, what neurotransmitters, what hormones are involved in aggression, how can that help explain why one person may act violently in a situation where another not. And then next lesson, we'll look at the genetic factors. Is there some sort of hereditary pattern there to the aggression? And then, as you can see there on the topic, the final part is looking at evolution. Was there potentially an evolutionary advantage to being aggressive? And I can imagine you're already thinking, well, maybe there could have been, but we'll save that to another day. That can be a treat for you. Okay, under the neural and hormonal mechanisms then, as I say, we're going to look at neurotransmitters. We've come across them before in other topics, and neurotransmitters are the nerve cell in the brain, your neurons' way of sending messages between each other, and these neurotransmitters are released between different cells into the synaptic cleft and released from one neuron and adopted, taken up by another. And we're going to look specifically at serotonin and dopamine, and how those two neurotransmitters are potentially involved in aggression. We'll then go on to looking at hormones. Hormones are slightly different to neurotransmitters. They are released into the blood and travel around our body, and again, how these chemicals can potentially lead to aggression. I know, sounds fun, doesn't it? Right, to begin with, neurotransmitters then. And the first thing we're going to look at is serotonin. And the idea is that serotonin is a neurotransmitter. As I said, it's the way that neurons send messages between each other. Serotonin is one of these neurotransmitters. And the idea is that a healthy amount of serotonin reduces the amount of aggression and would stop you becoming aggressive. So the idea being that if you have low levels of serotonin, that could lead to aggression, lead to impulsive behavior, violence, violent suicide, and all sorts of aggression. This was studied by Mann et al. In 1990. And in this study, there were 35 healthy participants given dexfenfluramine, easy for me to say, and this denflexfluramine, that was better, reduces serotonin, and so obviously lowers the levels of aggression. Reduces the levels of serotonin, and if the theory is correct that low levels of serotonin result in aggression, then you'd expect aggression to increase, and that is what they actually found. Just keeping your toes there, making sure you're listening. So they found that the reduction in serotonin led to hostility and aggression scores increasing in this sample. But this will become important when it comes to evaluation AO2. This is obviously AO1, but this was found in males, but not necessarily for females. And so looking at your IDA, is there potentially a gender bias here? And we'll come back to that when we look at the evaluation. That's one study suggesting that serotonin is involved. Low levels of serotonin is involved in aggression. The next neurotransmitter that has been linked to aggression is dopamine. And this is obviously a separate neurotransmitter that is involved in separate pathways in the brain. And the idea here is if there are too higher levels of dopamine, that could potentially lead to aggression. So Levine looked at this in 1997 and gave people amphetamines. So amphetamines are things like speed, Ritalin were given to people with ADHD. Or if any of you watch Breaking Bad, crystal meth, that's an amphetamine. Gave people these. You could argue nice study to be in if you like a bit of Breaking Bad, but not if you don't like aggression, because this increased the levels of dopamine, but as predicted by the theory, that increased the level of aggression. So what we've seen here is an increase in aggression, an increase in dopamine, leading to an increase in aggression. And so there's a bit of research there that suggests that was backed up by Butler. I think that's how you pronounce it. And they gave people antipsychotic drugs, and the aim of these antipsychotic drugs was to reduce levels of dopamine. And what they found was that in that sample, there was a reduction in violent behavior among delinquents. So again, that would, two bits of research almost at either end. So one saying if you increase dopamine, that increases aggression, and one at the other end saying if you reduce dopamine, that reduces aggression. So really stating a link there between dopamine and aggression. Okay, looking at the hormones then, as I said before, one of the main hormones involved in aggression is thought to be testosterone. Testosterone is the male sex hormone, and this is thought to play a significant role in aggression. Dabbs et al. Compared a group of violent criminals with a group of non-violent criminals. I want to see what the difference was between these two groups, and one of the main differences they found was that the violent criminals had higher levels of testosterone than the non-violent criminals. Non-violent criminals had lower levels of testosterone, so that suggests that maybe testosterone has a role to play in aggression as well. Lindman et al. Backed this up by finding that males who have high levels of testosterone act aggressively when drunk compared to those with lower levels of testosterone. Now, I know most of you are A-level students, so you don't drink. So I'll tell you a story from when I was growing up, and you tend to have different friends when they get a bit drunk. And there was this one friend that I had. We'll call him Mr. Ebbridge. And he tends to get really lovey-dovey when drunk, goes around telling all his mates that he loves them and, wells up a bit, really lovable rogue. So he maybe hasn't got high levels of testosterone, whereas you can imagine other people, when they get drunk, can get into fights. We've all got a mate, Dave. My mate, Dave, when he gets drunk, he gets into fights. We call him Fighty Dave. Not a very inventive group, but that kind of has not a great deal to do with the research, but an anecdotal account that kind of backs up the theory that testosterone might have some sort of role to play in aggression. Don't write that in the exams. Write about Dabbs and Lindman. The other hormone that could potentially be related to aggression is cortisol. And cortisol is known to inhibit testosterone. So it stops testosterone working. Inhibit is a fancy word for stopping. And so if you have high levels of cortisol, that's going to stop the testosterone working. So hopefully high levels of testosterone will see lower levels of aggression. However, if you have low levels of cortisol, you're likely to see more aggression because the testosterone will have more of an effect. And again, there's a couple of studies that have backed this up. So Verkennen has found low levels of cortisol in habitually violent offenders. So again, this is a criminal sample. We'll look at these samples when we look at evaluating. But again, in a criminal violent offenders, there are low levels of cortisol. So that implicates cortisol in aggression. And Tens and Kerry found low levels of cortisol in habitually violent school children. I'm glad I don't work in any of these schools, but that shows that maybe cortisol has a role to play as well. So these two different groups, so violent offenders as well as violent school children. Okay, evaluation then, and we'll go through again each of the neurotransmitters and the hormones, and look at how we can evaluate their role in aggression. So firstly, serotonin. Serotonin, we're pretty sure has a strong role to play in aggression, and there tends to be a lot of supportive research. So to go along with what we've already looked at, Raleigh et al. Conducted an animal study in vervet monkeys, and they fed them on a diet which would increase their serotonin. And so that showed lower levels of aggression. And again, those fed on a diet which would decrease their serotonin showed higher levels of aggression. So again, it supports this idea that low levels of serotonin would result in aggression. So you can use this study as AO2 as an evaluation to say, well, it backs up kind of what's gone before. We also, looking at animal studies, have found that domesticated animals, again a posh way of saying pets, cats and dogs that are docile and not aggressive, they tend to, when studies have higher levels of serotonin, and so would suggest again that their reduction in aggressive behavior is linked to their higher levels of serotonin. So lots of research here to back this up. And again, Bond, that's why the picture's there, found that drugs which raise serotonin, such as antidepressants, tend to raise serotonin, and serotonin's also known as the happy hormone, as we looked at in other studies before. That lowered aggression as well. So there's lots of supporting research, and we're pretty sure that serotonin has a role to play. So the best way to evaluate this is with lots of supporting research. Evaluation, the role of dopamine is kind of less certain, and so tends to be a bit harder to evaluate. One of the issues then is that we don't know about the cause and effect. Is it the dopamine comes first and that is causing people to be aggressive, or are we finding an increase in dopamine after the person has been aggressive? We don't know what came first really. There's been a study conducted, again, another animal study conducted on mice, and what they found was that dopamine was released afterwards. It was released as a positive reinforcer almost for aggressive behavior, and so may then increase the aggression. And so it's not that the dopamine was the cause of the aggression in the first place, but maybe it might help in the maintenance of aggression. So that's just an evaluative point to make about the dopamine. Okay, in evaluation of the hormones then, where we've just said that a good way to evaluate the serotonin is the fact that there's lots of consistent evidence. On the contrary to the testosterone, there's potentially some inconsistent evidence here. So Albert et al. Said that while many studies do show a correlation, not all studies do, especially when we're looking at the difference between why one person is very aggressive compared to someone being less aggressive. So maybe a distinction between aggression and non-aggression, so two very distinct groups, but when we're looking at variations in aggression, we can't account for that with variations in testosterone. And that becomes an issue that says, well, if it's the testosterone, can it be this theory alone that proves it? And that would potentially suggest no. Also, the research that we've looked at tends to have smaller samples of mostly men, so you're potentially getting a gender bias there. We'll come back to that later on. And so can you actually trust the research that this theory was built on? There also tends to be a difference between self-report and the severity of the crime as well, in terms of testosterone. There's also a question Mazur asked, that when these studies are defining aggression, is it actually aggression they're talking about, or is it dominance? And Mazur defined aggression as inflicting injury, whereas dominance would be seeking status over another. And Mazur suggested that, well, maybe testosterone actually has more of an influence over dominance rather than aggression. And that's quite a subtle thing to look at, and a subtle thing for testosterone, the role of testosterone, to be able to account for, and the theory probably doesn't do so. Bit of evaluation for the cortisol then. There is some research support for the cortisol. So they found that boys with low levels of cortisol are antisocial at a younger age than those with normal levels of cortisol, and have 3 times as many aggressive symptoms as those with regular levels of cortisol. So again, that kind of backs up the research into the cortisol. Really good evaluation here comes from IDA, I think, for the hormones and the neurotransmitters. And the big problem here, and we've looked at this in IDA, is reductionism. And we get the problem, and that's almost what I was getting at there with the testosterone, is that we're talking about a very complex behavior here. Aggression isn't just something that happens the same to all people in all situations at the same time. And to try and explain that by particular chemicals, it almost falls short. So you could have the same situation. Think of a bar fight, maybe. Not that any of you have been in any bar fights, but maybe a fight that you see in the street, and 2 different people are going to react to that situation very differently. One person may intervene while another runs away. And to say it's just down to different levels of hormones or neurotransmitters is quite reductive. It takes what is a very, think of being in that situation. It's very complex, lots of emotions, lots of thoughts and feelings and behaviors going on there, and it's reducing it down to very simplistic terms. Where have these differences in hormones and neurotransmitters come from? And so that's an issue there, definitely. Finally, again, already kind of been touched on, but there is gender bias in this research, definitely. A lot of the research, as already stated, tends to be on men, quite often on criminals as well. And again, you need to look at whether that research can be applied. We'll look at that more in the next lesson, where we kind of look at genes. A lot of the research there is in criminals, and can we actually apply that? But focusing specifically on neurotransmitters and hormones and testosterone in particular, obviously being the male sex hormone, a lot of the studies have been done on females. However, does this apply to, a lot of the studies have been done on males. Does this apply to females? Well, some studies have looked at testosterone in females, and some have actually found, Archer et al. Actually found that testosterone has a higher association with aggression in females. So the fact that the females have been almost ignored in the studies is quite important, because, well, actually maybe it's got more influence there, and this needs to be looked at in more detail. It's also been found that women with higher occupational status, so looking at CEOs and managers and high-flying lawyers, tend to have higher levels of testosterone, and that could potentially be due to assertiveness, which may show itself as being a bit aggressive. Yet another study has found that women with higher levels of testosterone have been rated as nicer. That kind of contradicts what we're looking at there. The best way that I've seen to describe this is that actually testosterone, maybe in females, maybe in males as well, but this is a debate you need to have. It's, issue debates and approaches. Is that, well, maybe testosterone has a role to play in status-seeking behavior, and so that would explain why they've also found that women high in testosterone have been found to be nice, because if you're nice, you might get a better status, so you might be promoted more, and so you'll be seen in a better light. But another part of status seeking would be being aggressive. It would be trampling over the opposition, and going for something, and maybe being selfish, which could be seen as aggressive as well. So this status seeking could explain why we have these different findings between testosterone and aggression, and maybe males and females. Okay, that was a bit of a whistle-stop tour of hormones and neurotransmitters. More can be found on pages 72 and 73 in the Cardwell and Flanagan textbook, and we'll go through a bit more in class. And you can look forward, as I know you always do, to the next video, which is going to be on the genetic approach. Okay, thanks for listening. Bye.